Hey, willkommen. That's my Norwegian so far. Thank you for coming. I'm here to talk to you about Jenkins X progressive delivery. So let me start asking you some questions. Who came to my talk last year? 2 people. Okay. All right. So I'm not repeating much, but maybe some introductions are in order to help everybody else understand. And who is using Jenkins? Raise your hands. Like everybody, almost. Who knows about Jenkins X? A lot of people. Who is using Jenkins X? 1 person. Okay, good. So I'm Carlos. I'm here because I have done some contributions to Jenkins and Jenkins X. I'm the author of the Kubernetes plugin for Jenkins. Been doing a lot of Kubernetes stuff. Who's using Kubernetes? Yeah, of course. And I work at Adobe as a cloud engineer now, and I've been contributing to a lot of open source projects, Maven, that you probably love or hate, and Eclipse, Puppet, Jenkins, and so on. And I'm also part of the Google Developer Experts. I mean, we're talking about Google Kubernetes Engine a lot, and all the demos you'll see run there. So let me start a little bit introducing what is progressive delivery. So progressive delivery is a term that was coined like at the end of the last year. The name is new, but you'll probably recognize a lot of the features or the implementation details of the techniques in progressive delivery. But I'll also show you how these things can get automated, which is something that was not easily doable before. So progressive delivery is one term that we call all these approaches that avoid deployments that are either fully successful or fully disaster or unsuccessful. So it tries to avoid problems with the deployments as a whole thing. And it does that. All the techniques you'll see, they do this by having 2 versions deployed all times, at least 2. You have the previous version and you have the new version, and you run both versions at the same time. And using these techniques, you make sure that the users go to one or another in case, depending on whether the new version is successful or is not. And we evaluate the results of the new version with real users in production. So we make sure that our version is being successful, and we gather metrics. And in case that it's not the case, we have an easy way to roll back to the previous version. So continuous delivery is hard. We all know that, probably. And progressive delivery tries to make continuous delivery easier to adopt by reducing the risk associated with continuous delivery and continuous deployments. So what are these techniques that you probably already heard of or you're using? So one is rolling updates. This has been popular for years. This is an example of, or a graph of what you can do today with Kubernetes. It will allow you to do rolling updates, rolling the new version in 1 container at a time. I mean, we've been doing this with bare metal machines, VMs, and now you can do it with containers. So the trick here is you don't update all the things, all the VMs, all the containers. With the new version at the same time, you just roll one at a time, and you check that the new version, it's not blowing up before rolling to the next. And if it is, for whatever reason, there's some failure, you can stop the rollout, and then you still have some containers, some VMs running on the previous version that users still are going to be getting the new version from, and everything is going to work. So Kubernetes does this. When you do the rolling update, it's going to basically increase change the pod versions, the container versions in the pod, and it's going to do one pod at a time. As long as you have multiple replicas, it's going to go one by one. Another one that's been very popular is blue-green deployments, where you have the old version and the new version running at the same time. The problem with this is that you need to have twice the capacity you may need. And then you have a router, a switch, a load balancer, DNS record, whatever it is, in front of both. And when you want to show the new version to your users, then you just point it to the new cluster. And if for whatever reason there's a problem with the new version, you just have to go to the load balancer and point it to the old cluster. And hopefully, not a lot of people notices the problems, but you have a quick way to roll back. Then a specialized version of this is canary deployment, which is more new, I guess. And it's something that is being used by Facebook, Netflix, a lot of these companies, where you just send a subset of the traffic to the new version. So you have the two clusters, old version, new version, and you're sending a percentage of the users to the new version. You can say a 1%, 2%, and keep increasing it until you finish the rollout. There's a lot of ways you can do canary deployment. You can just pick random people, random users at a percentage. You can use HTTP headers. You can use location-based. There's some papers talking about how some companies deploy to New Zealand first because the population represents pretty well statistically, I don't know, the US. And so they're deployed to New Zealand first and then see how that works and then deploy to the rest of the world. And yeah, you try in some users, you keep increasing how many users receive the new version, and you do so until you reach 100% of users. So one thing I like to say is monitoring is the new testing, because you know when the users are having issues in production, and you can respond to these issues automatically, right? With testing, unit testing, integration testing, typical traditional testing, you can only test what you think may fail, but users will always find a way to break your application in very new and interesting ways. So that's why you need to have something that will tell you what's wrong happening in production. There's always so much you can do with testing. And also monitoring will give you the base for this automatic solution of these problems, automatic rollbacks, automatic notifications, things like that. So Jenkins X, for those of you that don't know yet, is a new version or a new project, open source project, that's a better way to say it, that was started last year, I think it was, or was this year? Last year, yes. And the only thing that has in common with Jenkins today is the name. So it's a new CI/CD platform that runs on Kubernetes, and that's the main requirement. It runs on Kubernetes. You can deploy to Kubernetes, and it's going to make your life easier, but you can also deploy to other things, but it runs on Kubernetes. And it includes a bunch of tools that you probably heard of, and if not, I'll go through some of them. And it just prepackages all these tools in a very nice way so you don't have to. So it obviously uses Docker for containers. It uses Skaffold, Skaffold, that is an open source project by Google that allows you to abstract how you do Docker image builds. Draft is a project from Microsoft that allows you to generate scaffolding for your projects. You can generate Docker files, you can generate Helm charts, and Helm is the package manager for Kubernetes. Right now is the standard package manager for Kubernetes. Jenkins X also includes Nexus as a repository manager for all your artifacts, so you don't have to go to the internet every time. Chart Museum to host the Helm charts. It's like a repository for Helm charts. And I'll talk about the other ones, Tekton and Pro. So Tekton is another new open source project that spun out of Knative, a project from Google. So Tekton used to be Knative build. It's a pipeline engine for Kubernetes, where all the steps in the pipeline are running as containers and pods, right? So you'll see a lot of, or you've probably seen a lot of new tools that do this same thing. So you define some pipeline, and then every step is one container. You define what image it is, what's the starting workspace, and then it just runs and keeps doing things. And all of these runs separately in different containers. So Tekton does this in any Kubernetes cluster, any standard Kubernetes cluster. Pro is a project from the Kubernetes ecosystem that implements this concept of chat ops, which is how you interact with pull requests. And let me show you. So what you can do with chat ops. So I have a pull request here that I opened before. So when I open this pull request, my bot is telling me, this pull request is not approved, somebody has to approve it, and I can do commands here like /approve. And the other things that I can do, so I could do /approve, /retest, different commands. I can do meow, and my bot is gonna respond me with pictures of cats, right? So that's what the internet is for. Remember. So this is the idea of chat ops. I interact with the bot. The bot is gonna do everything behind the scenes for me. So I can request multiple people to approve my pull request. So I'll have to come here and say approve. And when everything is approved, this is gonna be automatically merged. I don't have to do anything out of it. So Helm, as I mentioned, the package manager for Kubernetes. Skaffold, again, the abstracts the Docker image build. If you use Kubernetes, you know that typically Docker image builds require mounting the Docker socket into your container, something that is not very secure or not at all. So Skaffold allows you to use multiple ways of building your Docker images. One is the typical Docker build something. But the one that Jenkins X uses that is very nice is another open source project that is Canico, that allows you to build Docker images with your Docker file. You don't have to change much or anything, most of the cases. And it will build the Docker image without needing the Docker daemon. So you can run Canico totally safe, or mostly safe, in Kubernetes. And it will build and deploy your Docker image to a Docker registry. Skaffold also has other options, like it can run the Docker build in Google Cloud Build. So basically, it's like as a service thing. Uploads the contents of the directory, and Google Build does the build for you. And Jeep, which is a project plugin for Maven and Gradle, where it will do Java image builds in a very smart way, is using the JDK image and then appending your jars, your dependencies on Maven as different layers. So you don't even have to write a Docker file, and it will optimize the creation of the Docker image. So if you are a Java person, then that's something you could do. But again, Jenkins X is now using Canico for everything because of the advantages of not having to expose the Docker socket and the Docker daemon. Draft, again, what I mentioned, it will generate Dockerfile and Helm charts. So you have a Java project or any project, You run draft against it, or you run JX import to import it to Jenkins X, and it will run draft for you. And it's going to detect, and it's going to say, oh, okay, this is a Java project. So I'm going to create a Docker file for Java with from OpenJDK Docker image. I'm going to do these things. I'm going to create Helm charts to deploy a Java application. So it's going to do all these things for you. And then you can customize them afterwards. So you can, that way you can bring your existing projects, even if they are not Dockerized or anything like that, you can bring them into Kubernetes. And again, that's with JX import. So all of that ties together because Jenkins X now, and I work on this integration, has some features to do progressive delivery. So with Jenkins X, if you are not familiar, you can deploy applications automatically. Jenkins X provides you different environments, staging, production. So everything you commit to master gets deployed to staging. That's a Kubernetes namespace. And you can manually promote things from staging to production. That's another Kubernetes namespace. So what you can do, and that's the website with instructions in detail that I show you now, is you can do a canary deployment in production. So for that, you can only have, if you have Jenkins X running, you only have to install 2 add-ons. Jenkins X has this concept of add-ons that are new services that run on your Kubernetes cluster. So you just have to install Istio and Flagger. Istio, anybody heard about Istio? Yes, everybody, almost, well, half of the people. Istio is a service mesh, one of the 100 that exists today. So it allows you to do very nice things. So it will connect your services, your containers. It's going to create this service mesh network, virtual network on top of your Kubernetes cluster. All your services are going to connect through Istio. You can secure this connection between services by automatically encrypting everything. And you don't have to change your application. This runs at a different layer. You can control how this traffic is going. So you can, at the Istio level, you can send things to one version of the service running things to another version. You can do based on HTTP headers. You can do all sorts of complex control of the traffic. And you can also, in the observe part, it will get metrics of your application, and it's going to store them. And you don't have to touch the application at all. That's the most interesting part, right? This runs like an infra layer, and your application runs on top, and you don't have to touch your application. So you're going to get metrics. You're going to get what type of HTTP response and request you're getting, how long is it taking for you to process the requests, how long it's taking to return the response, all these things. So these metrics are stored in Prometheus, which is probably the most popular monitoring tool in Kubernetes. And that's where we're going to get those metrics from. And another project, you see, like, we are just making, using the best projects we can find everywhere. It's Flagger. It's a project that started by Weaveworks that automates the promotion of canary deployments in Kubernetes. And it's going to use Istio to control how the traffic goes to the old version and the new version. And it's going to use the metrics from Prometheus that are populated by Istio to decide whether the deployment is successful or not. So it's going to do all that automatically. And the only things you have to do to enable this in your Jenkins X application is in your Helm charts, you can say enable true and canary. And the interesting part here, on the canary analysis, so you're saying, I want to check every 6 seconds, and I'm gonna do my rollouts every 60 seconds, starting at 10% and finishing at 50% of the traffic. So I'm gonna roll it out to 10% of the users, 1 minute later to 20%, 1 minute later to 30%, 1 minute later to 40, and then 50, and then 100. So that's how the rollout is defined, and you can customize this. So you could say 1 hour, whatever you want. And threshold 5 means if the metrics fail 5 times, roll my application back. So it's all hands-off once this is configured. Now the metrics part is where you can define what metrics in Prometheus you want to watch and what's the conditions that define a successful metric or a successful one. So with Istio request total, I'm saying I want 99% of my requests to be non-500 to be successful. I want my request for the 99 percentile, I want the request to be under 500 milliseconds. So those two metrics, I don't have to use my application again. Those two metrics are injected by Istio automatically, and I'm just using these two. I could add more metrics. I could add my own metrics. Imagine you have a shopping cart application, and you want to add metrics like number of orders in the last 5 minutes, 20 minutes, or whatever. And you could say, you know, if I'm not getting any new orders in 30 minutes, in 10 minutes, or whatever, roll the version back because there is something wrong with the application. And with that, whenever you do a promotion of Jenkins X applications, you just get a canary rollout. So this is the typical way to promote things from staging to production on Jenkins X. If you have this enabled in your Helm charts, it's going to do that for you, the canary deployment. Oops. So the way it works, and I'll show you in a demo in a second, I have my Flagger service running that is configuring Istio. Istio uses this concept of virtual services. That is what's gonna say how much percentage of traffic is going to one version or the other. I'm gonna have two versions running, my primary and my canary, with their own Kubernetes services. So Istio is gonna send some traffic to the primary and some traffic to the canary, as defined here. And Flagger is going to automatically update Istio virtual service. So it's going to update it to 10%, 20%, 30%, and so on, by watching the metrics in Prometheus. And whenever the metrics fail, it's going to change the virtual service to send all the traffic to the old version. If you have a Slack configured, you can also get Slack notifications. And this is a different way of seeing how the deployment happens. So at the beginning, you have version 1 deployed. Then when you change the version 1, you want to upgrade to a new version, it will create a version 2 deployment. It's going to send traffic to both version 1 and version 2, these percentages. And whenever this is considered successful, the version 1 is scaled down and the version 2 becomes the new version, the existing version. I'll show you this in a demo. This is what you can get in Slack. Whenever there's a new revision deployed, it will tell you, starting the canary analysis, and these are the options that are configured. And if it fails, it will tell you in Slack. So let's show to the demo time. I have my Croc application running on staging and in production. So in production, I have version 0016 here, you see. And in staging, I have 0070, which is the next version. because in production I had this version that was shooting crocodiles with lasers, which is so much fun. And obviously there was some complaints about, this is not good for the environment and animals. So we made some changes that are already in staging. I went through this before the talk, and we are just throwing fish to crocodiles, a lot more friendly for the environment. So I want to deploy this version to production, and I want to do a canary deployment, just in case something is broken or the users find a way to break it, which they always do. So this is 0069, 0070. Okay. So I have something running continuously that is going to tell me hitting the application and showing the version. And let's go here and do JX get applications. So it will tell me staging is 0070, production is 0069. So I want JX promote, Croc Hunter Java, version 0070, environment, production. So what this is doing behind the scenes is Jenkins X also uses the concept of GitOps. So changing the version in my environment, in my namespace in the cluster, means creating a pull request against my definition of environment, which is here. And everything that is running in my cluster is defined as a config file in Git. So upgrading a version is changing my 0069 to 0070 in my production environment. So this is all defined in Git. If for whatever reason my cluster blows up at some point, I can apply the same files to a new cluster and everything gets back to normal. So this is gonna be automatically, let's see, built, deployed. We can tile some logs here to see when this is happening. And when this change is built, what's gonna happen? Version 7 is gonna be deployed to production. And that may take a little bit, but I'll show you more things in the meantime. Okay, this is a Grafana chart. Okay, this is running. Let me see that everything is working fine. Just in case. Okay, the pods are initializing, so whatever it takes to do the build. Flagger also includes this Grafana chart. On the left-hand side, I have metrics from the primary version, which is the previous version. And on the right-hand side, I have the canary version. Nothing is there yet because it's not started. And I can see like the request volume, success rate, request duration, CPU, memory usage, network, etc. So I can see how my deployment is happening. Okay, so this is still initialization. Sometimes it takes a little bit long because it happened to end in a new node. And I'll show you, this is running on Kubernetes engine, so I have a cluster that is auto-scaling, so I don't have to worry about adding more nodes to Kubernetes or anything. It will auto-scale up and down. And what may have happened is that it needs another node, and maybe it takes some time, but I don't know yet. And I can see in my, because it's in Google Kubernetes engine, I can see all the logs from my pods, also in the stack driver in Google. And Okay. All right. So yes, this is building now. So I have another. Okay, this is going to be more interesting. I'm gonna tail the logs of Flagger, and I'll show you what happened before. While this goes up. Oh, okay. No logs here. Well, we'll wait. We'll wait for the deployment to finish. So this is hitting my my application, version 69 still. All right. Still cloning things. Okay, now it's applying the Helm chart, so everything looks better. I can see if my pull request is still there. Okay, my pull request has been merged, so this will start the deployment in a second. Let's take a look at the Flagger logs, which will start soon. So what's going to happen, my health chart is going to be applied. So the deployment of the application is going to change my image version to the next one. And Flagger will miss that. And instead of letting Kubernetes do that, it's going to hold it back and it's going to do itself the rollout with the parallel versions and the usage. We can take a look at. So this is all. Well, if you want an advice, if you want to become like 7x Kubernetes engineers, just do an alias from kube control to K, and it's going to save you 7 times the typing. So you can do just K, so JX production, get deploys. Right. So I have Croc Hunter Java primary. Okay, so this has started, doesn't it? No, not yet. Okay. Okay, there it is. New revision detected scaling up JX Croc Hunter Java. Okay, so Flagger has detected there is a new version and is doing the scale up. So in a second, it's gonna tell you I'm sending 10% of the traffic there. I can see I can get the Istio virtual service. So if I look at the Croc Hunter Java YAML, here at the bottom, you see that the primary version is getting 100% of the traffic, the canary version is going to get 0%, and this is what Istio with what Flagger is going to be updating every minute. So that's Istio configuration, and there it is. So advanced wait temp, and you can see up here that some of the requests are getting the new version, while the other ones are getting 69. So some of them are getting 70, so it should be a 10%. Let me make it bigger. Woo. So 69, come on, 70, 69, and so on. And now I can show you in Grafana. There it is. So I can see in my canary, I'm getting 100% success rate, and it's getting some volume here. It's just very small for now. So There it is. So I'm getting traffic on the Canary version. And this is going to be monitored by Flagger based on the metrics on Istio. And I didn't have to do anything in my application. I didn't have to change anything. So this is all automated, and you can apply it today to whatever application you deploy to Kubernetes. Now, this is cool, having automated Canary deployments, but what is even cooler is that it will detect if there are any problems. So this is now 20%. Let's simulate some delay in requests. So I'm going to run this from inside Kubernetes. Okay, there it is. All right. So what I'm doing is making some requests take longer than expected. And the other thing I can do, I can make them fail, so you can see what happens. Actually, I'm gonna do that because that's gonna be faster. Here. Okay, so I'm making some requests, get 500 errors, and eventually we'll see how this success rate drops. I just gotta make sure that I do it fast enough before the rollout finishes, which is always the tricky part. And we'll see. Still running. It's already at 30%. The deployment. Okay, there it is. So here. The advancement success rate is 76%, which is less than the 99% that I said. So it's halting the advancement. If we go at Grafana, we can see that the success rate has dropped. So Flagger has noticed that, and he's saying, I'm not rolling out to more people. I don't want to add more users to a version that is failing my metrics. And because I think I have the threshold set to 3 failures, after 3 failures should automatically do the rollback. So that's probably 3 minutes, what it's going to take. But that's the interesting take, right? This is going to detect whatever is happening in production. It's going to use these metrics, and it's going to automatically, there it is, 63%. It's going to automatically do the rollback. So no more excuses about not deploying to production on Friday afternoon, because this will hopefully get any of those issues if you define them correctly. Let's go look at the application one last time. So some people get 69, some people get 70 already. So that's working fine as expected. Some people are getting 69, some people are getting 70. So you got 1, 2 times the metrics have failed. And we just wait for a 3rd time. And the rollback should happen. Flagger also supports other service meshes, not only Istio. So it's adding more support to other ones in case you are interested. There it is. So the 3rd time. And probably just 1 more minute. I don't know about you, but minutes take longer when you are here and presenting to everybody. I don't know if that's well, I can tell you something about the app while we wait. So that's where you can get, I have 2 versions of the demo. One is on Golang, the other one is in Java. So you can choose. It's the same application, different, just different language. Okay. And it's using Quarkus. Anybody has heard of Quarkus? Yeah, some people. So, which is a new Java framework for microservices, and it has some interesting things like it uses Graal. It can compile to native, so you can create Docker images that do not need the JDK. So that's a cool part. You can make smaller Docker images if you're interested, and they will start in like fractions of a second. So it's a bit of a trade-off between long-running things and things that you need to start quickly. But if you want something that starts quickly, then Graal it's for you. And here it is. Okay, so rolling back, Croc Hunter, failure checks threshold reach 3, and scaling down the canary version. So now all the users are getting version 69. So that has happened automatically while I was just wasting time here hand waving. So that's what it is. If you have any questions, I'm happily taking them. Don't forget to give feedback, and